Hello and welcome everyone. So some of you may know, last week we announced our latest release of Weave GitOps, where we have added trusted application delivery and policy as code capabilities. And today we're going to talk more about what that means and show you how it works as well. But before we begin, I just want to mention a few housekeeping items. This call is being recorded and we will share the recording and the slides with you tomorrow. All participants are in listen-only mode, so if you'd like to ask a question, please use the Q&A panel at the bottom of your Zoom menu, and we'll address those at the end during the Q&A portion of the webinar. So I'd like to introduce you to our speakers today. We have Steve Waterworth, who's a technical marketing manager. He's been in technical roles in the app performance management space since 2004, where he's seen numerous technical revolutions and market disruptions, giving him a unique insight into the rapidly changing DevOps environment. I'd then like to introduce you to David Stauffer, who's our senior product manager. For David, the most exciting job in the world is building the best products for customers. He's passionate about all end users, and he has experience working within many startups across the globe. Some of his most recent work has involved making edge computing real through Kubernetes. And then I'd like to also introduce you to Mustafa Migahed. He's also a senior product manager. He's currently focused on integrating policy as code capabilities and features into Weave GitOps to enable developers and operators to have a trusted application delivery workflow. He brings many years of experience working across multiple industries and technologies. Mustafa is based in Cairo, loves playing video games, watching football, but mostly he enjoys his time playing with his 5-year-old daughter. And last but not least, we have James Wilson, who's one of our senior engineering managers. James has a wide array of experience for building products that improve and simplify people's lives. He has authored a dozen courses on Pluralsight, ranging from building UIs in iOS to coding in Go. And he's worked in many fields as a technician and also as a developer, building on platforms such as .NET, iOS, Kubernetes, and Google Cloud. And in James's free time, he enjoys spending time with his family, playing video games and reading. And with that, I will hand you over to Steve to begin. Thank you.
Hi there. Okay, so before we get started, let's just sort of introduce the Weave GitOps platform. So it's all about GitOps. It's part of the Open GitOps. We go on those 4 foundations of Open GitOps, of declarativity, immutability, continuously reconciled and pulled. So we align with that. But say Weave GitOps is a platform, so it adds trusted delivery, observability, and hybrid multi-cloud cluster management. More of which later is what this is all about. So let's move on. So it's all about really just running your applications in Kubernetes one pull request at a time. So automating that entire GitOps pipeline and helping you achieve just that, rapid deployment of new features and fixes. So what's new in this release? Well, actually quite a lot. We have that trusted delivery, policy as code. We have a Terraform extension, so we can do GitOps with just about everything. We have some new observability dashboards. Again, so we're going to go into all of this in detail as we go through. We have liquid metal, which is micro VMs, really interesting technology that. And then we have a VSCode extension, so you can do absolutely everything in your IDE. And last but not least, the Flux subsystem for Argo. So let's dive into those in a bit more detail. So we'll start off with trusted delivery. So this is policy as code. So this is, again, we're using Git, so the policies are in Git and managed in a GitOps way. And then those policies are used to check the infrastructure as code. So all those Kubernetes manifests we're pushing through. So they're used to check those at various stages. And those policies cover things like security. So are we only pulling containers from approved registries? Are any pods running with more elevated permissions than they perhaps should be? Then they're covering off resilience. Have we defined all those things that make Kubernetes work properly? So have we got those health probes defined? Have we got resource limit sets? Have we got a suitable number of replicas? So on and so forth. So checking all that good housekeeping has actually been done. And then coding standards. Most organizations have standards for the way they annotate and label the resources inside Kubernetes to make management and auditing so much easier. So again, we can use policy as code to validate that those coding standards have been adhered to, that everything is in fact labeled and annotated correctly. So the architecture looks sort of something like this. At the heart of it is the policy engine, and it looks after and validates all those various assets, such as containers, volumes, Kubernetes config, service meshes, so on and so forth. The policies feed into that. They're managed by Git in a true GitOps way. And then the output is things like reports, notifications, and dashboards. So we can enforce those policies at every step. So when doing a Git commit or a PR, we can fire off a GitHub action and validate those changes. Although through a pull request, we're going to go through that peer review and approval process, but alas, humans are not that great at linting several hundred lines of YAML. Machines are much better at that, so let the machine do the work. Similarly, at build time, we can sort of integrate in, for example, with Circle CI. So as part of that, as part of the build process, we can perform our policy checks and fail the build if there's a problem. And then last but not least, I guess really the ultimate backstop is at deploy time. So we have a Kubernetes admission controller, which checks the manifests as they're applied to Kubernetes. And again, if they're being violated, if we have any problems with those manifests, that admission controller is going to block that deployment. So you can't actually apply the changes either directly or through an API. That's your ultimate backstop, and that's great because that's going to stop any maybe accidental kubectls or possibly any malicious kubectl applications there. And then finally at runtime. So because building all this into your pipeline is great, but what about those clusters that you don't have in a GitOps pipeline, those applications that aren't in a GitOps pipeline? You've got all that existing real estate and you want to monitor it. The runtime agent can get deployed out onto those existing clusters and look after those clusters and the applications that are running on them. And again, you will get continuous notification and dashboards on any violation. So very good then at for checking your compliance against the various standards, and very good for being able to produce reports at audit time. So what does it look like? So our typical GitOps workflow looks very much like this. Our developer creates an app, which is essentially a pull request against the management repo. That's reviewed, approved, merged in, and then the GitOps reconciliation kicks in and deploys that to the cluster. So this automation is great, but of course it automates everything. Even if the configuration is maybe not as good as it should be, it's still just going to pass it straight through. So adding policy as code puts in additional checks, which will flag and block any bad configuration before it gets through to the cluster. So from our engineers' point of view, absolutely nothing changes. In fact, it just makes their life easier. They do their Git commands as they always have done, only now they'll get better feedback on whether they might need to tweak that pull request because they've forgotten a health probe or something like that. So it really just makes life a lot easier, and there's nothing new to learn, just regular workflows. So that's policies code. Let's have a look at the Terraform extension. So this is really GitOps for everything. So if you think about it, a real application is more than just some deployments inside Kubernetes. There's quite often things that are external to Kubernetes, big data stores, message queues. Then you've got all your cloud type stuff with your IAM and DNS. So there's a lot of other potential resources that need to be managed, and of course Terraform has a very large catalog of things that it can manage across many platforms. So these can now be brought into that GitOps fold and managed in exactly the same way, and getting alerts against drift detection, also been able to take manual or automatic remediation upon an alert. So this could be great for sort of ensuring that identity and access management controls are consistent across the estate, that DNS records get updated as things get deployed, whatever. The use cases are many and varied for that. So it really extends that reach of GitOps outside of just pure Kubernetes. Liquid metal, now this is really quite exciting and new, not something I know too much about, and David will be covering this in a lot more detail later on in the call. But really, it's about getting Kubernetes up and running, primarily at the edge. It's a great use case for edge computing. So rather than using lots of individual machines or sort of trying to stuff them into containers like in a kind sort of way, we're using micro VMs on the bare metal. So each component part of Kubernetes goes into a micro VM. So this is really good. It gives you a lot more flexibility in how you deploy your Kubernetes. And obviously, then you get advantages of having a VM over a container, like direct access to hardware for acceleration, for like 5G networks, artificial intelligence, those types of compute tasks. And it really takes that from EKS anywhere to EKS everywhere. And the real plus point is no VMware needed. So you can manage all those micro VMs without needing VMware. But David will cover that off, and I think this is a core part of our demo later on, so stay tuned. It'll be well worth watching. VSCode Extension. So this is a little something we're just coming through the pipelines at the moment. So really, as you can see here, it adds a Weaveworks GitOps button to your IDE, so you can basically do absolutely everything in the IDE without having to pop out of that and into different dashboards or getting into or using Lens or anything like that. You can do all of that inside your IDE. And if I quickly switch over, so here is, in fact, my VS Code. I actually use it all the time when I'm doing some work. And we've got the Weaveworks GitOps bit happening here. This is my cluster, and then these are the various GitOps components. So these are basically the workhorses for GitOps, and I can look at any one of those. Oop, there we go. Just a slight pause on the network there. So that brings up then the details on this deployment. I can also right-click and go straight into the logs, and this is really handy. So it's all the sort of stuff you could do from the command line, but point and click, do it quickly and easily, all inside your IDE. It shows you all the sources. So I've got, this is going against the development environment I'm working on at the moment. So we've got a bunch of resources defined here. Some of these are Helm charts, some of them are customized, as you can see here. And again, we can look at any one of these guys and drill in and see the detail all within the IDE. You can also do things like actually create Flux components in context inside the IDE, but I don't actually want to mess with my environment currently. It's more or less working. So that's the VS Code extension. Really just do absolutely everything inside your IDE. It's in preview at the moment. You will not find it in the marketplace for VS Code. You have to do a manual install. We can go to GitHub, Weaveworks VS Code GitOps tools, and you can download the extension from there and deploy it manually. At some point in the not too distant future, it will be published into the marketplace. Finally, Flux subsystem for Argo. So if you're already using Argo, but maybe you have some frustrations or some concerns with Argo and you want to migrate to Flux, but of course what you don't want to do is like do it in a big bang, is like shut all your Argo stuff down and try and get everything instantly replaced with Flux. It's probably not the best way of doing it. So this is really where where this comes in when you want to migrate away from Argo into Flux. So it allows you to visualize your Flux components inside Argo, so you can actually run both side by side, so you can continue to use your legacy Argo whilst migrating over to Flux, and do it all in the one UI and not have to constantly flick backwards and forwards between two different UIs. So then of course, you'll get all the benefits of going with that Weave GitOps built on top of Flux with complete Helm support and, of course, trusted delivery. So that's enough of slideware. Now it's time for some real action, and I'll hand you over to David, who is going to do the demo. David, you're on mute.
Oh,
there we go.
Hello. So now, sorry. I just said good morning, good evening, depending where you are. Let me share my screen and find the right. Yeah, that's always a bit messy. So what we're going to do today is a couple of things. So we're going to provision a cluster with dynamic defined profiles. So profiles is what we use for your basic loadout, because we all know that Kubernetes comes pretty much bare bones, and Steve didn't go into details of this, but basically what we have is a system that lets you bootstrap this cluster components, for example, like Prometheus or like the policy agent, in a declarative way. We're going to use liquid metal to provision this cluster. And basically what you're going to see is how we bring up a cluster in an incredible speed based on Firecracker, the micro VMs, on Equinix packet bare metal nodes. If you're wondering what is Firecracker, Firecracker is well powering AWS products like, for example, function as a service with Lambda or EKS Fargate. We're going to see as well how we really make the first steps to treat clusters as kettles. So what does this mean? The first thing we're going to do is we're going to bootstrap our GitOps engine onto the cluster. And basically how the bootstrapper works, it's just looking out for a label. And if a cluster matches, for example, a certain label, it will kick off the job, make sure our GitOps engine is ending up on the cluster, and then basically pulling all the configuration that it needs. And this will include basically in the demo today, the profiles, the cluster components we want, like Prometheus and our policy agent and configuration. So we will see how this profiles, this cluster components get installed automatically. We're going to add policy as code via GitOps. We're going to see admission control in action, how basically policy prevents you that anything bad even happens to your cluster. We're going to see how we can even shift further left, and we're going to see how we can do commit time policy validation and remediation. And we're going to see how basically we provide you as well with a graphical user interface to really see what is happening with your applications in a GitOps view. So this is what we're gonna show you today. And the first thing we're gonna do is we're gonna switch to our UI. So this is what you see, our Weave GitOps UI. And you can see here in my dashboard, these are my connected clusters, my very small fleet currently, and we're gonna create a new cluster. So the first thing you will observe here is what we call cluster templates. So what we're gonna use today to show you how we bootstrap a cluster is Cluster API. And if you're wondering where are these templates living, I can surely show you. So of course, the templates are in a Git repo. Sorry, this is basically the repo we're going to use, or we are using. This is our management repo. If we go to apps, copy, templates, here you can see basically our templates, and we provide as well a small markup language. We actually are currently trying to upstream to the Cluster API project, which defines basically the guardrails. If you can see, for example, here as a platform operator, we want only to allow in a self-service fashion that you can choose between this free Kubernetes version, or between this kind of number of control planes, or this two CNI we support. And we can put these options directly into the template and make sure that when a user is self-servicing these templates, that only these options are visible. So if we go now to the next step and we say we want to create a cluster, this is this render template. And if you are careful and you just watch, so first of all, I'm going to give it a name and I'm going to call it liquid 25. And if you have seen, we had only these two options. These were our guardrails, and we're going to choose Cilium. So in this case, we need as well to define our control plane IP, and we're going to say it's number 25. We're going to say how much control planes we want. If you look, these are the guardrails we set, and the same for our Kubernetes version. And we're going to say how much worker machines we want. We're going to say 2. This should be fine for this cluster. And now comes the interesting thing. So if you are looking, I cannot even deselect Prometheus because the platform team decided, for example, that Prometheus needs to be on any cluster. So this is as well defined as an annotation. Yeah, I'm not going to scan right now the template in too much depth, but this is a notation to the template. And what I'm going to do is additionally, I'm going to choose our policy agent. So we want to as well to make sure we install the policy agent. And this is basically the dynamically part. So very similar to an app experience, your users in a self-service fashion can select the authorized cluster components you as a platform team have authorized and labeled appropriately, and make sure that this are basically then there for a self-service. So what we're going to do is as well, we're going to define the self-service, and what we need to inject is a couple of information. We need to say what account ID is this. This is some useful metadata, and this is cluster ID is liquid 25. And we need a certificate. So we're going to as well automate this later on, but for today's demo, I already have prepared here my certificates. I'm going to copy this and I'm going to replace this. And this is basically what we need to inject in the values.yaml for this particular Helm chart. And now this is the GitOps portion. So we're going to basically create a pull request. So first of all, we need to authenticate with Git. So I need to authorize this with my Git account so that we can actually write the repo. And now we should be able to create this specific pull request. So if you remember, we called it liquid 25 and it appeared here and you can see the state. It's a creation PR. And now we directly from our user interface provide you the deep link to this pull request. So let's observe what we have generated. We have generated the cluster manifest. This is basically the rendered cluster manifest from the template. And B, we instruct directly Flux to bootstrap this Helm releases once Flux is up and running onto the cluster. And we added as well something additional, which we call layers. And basically with a layer, you can instruct the dependencies. So we can make sure that your Helm charts are provided in the right order. So for example, you probably cert manager before you do something else. And basically this makes this possible. So we can hear this all looks good. We have our keys and everything, what we need to establish our connection. So we're going back and we're going to merge this pull request, right? So this is the general GitOps flow. And now we can delete this branch and we're going to wait what happens here. So in a couple of seconds, we should be already ready to basically pick our kubeconfig. If everything goes nice, but it should be. So we just need to wait that basically Flux is reconciling this into the cluster. Let's not forget if that basically what we are doing is GitOps. So this is now added to the management cluster, this new CRs, and we are waiting that they are getting reconciled. So now we can see the cluster is already found and it's starting to provision. I didn't check the time, but it was quite fast. So I download the kubeconfig. And now what I'm going to do is, for this demonstration purpose, I'm going to switch to Lens and I'm going to add our new kubeconfig. I think we called it liquid 25. And we have it here, and we're going to connect to this cluster. And it maybe takes a second. It's not yet completely up. It's not reachable yet, but it should be there in a second. Yes, this is bootstrapping. Now you can see it's there. So this basically was the time it took to bootstrap this cluster. And now we can really observe what's happening. So we can see our control plane is already up. I think it took me not more than a minute. And in a couple of seconds, we can see how our worker nodes will come up. And we can then start to look into what is happening with our workloads. So let's go into our workloads. This is yet empty, but this is probably because I'm just looking in our default namespaces. Let's watch in all our namespaces. And we can see how our kube API is coming up. And we can see how our first services are coming up. So let's give this a moment. This is a live demo. So I mean, probably all know how long it can take to bring up and bootstrap a cluster, but look how fast this is. So here we have already Flux coming up. Our Weave GitOps engine is coming up. And when this is up, this is the first thing we do. I'm going to repeat this, is our bootstrapper makes sure that this cluster is as well provisioned, our GitOps engine. And once this is up, we make sure that all the right manifests are going into this cluster. So if we give this one more moment and this pods go from pending into running, which should happen any second, then it will directly bootstrap our cluster components, and it will first bootstrap Prometheus, because Prometheus is one of the foundational layers. And then it will start to take the policy agent, which is basically has no declared layer. So let's give it another small moment. We can as well see that now our two worker nodes are already up and running. So our cluster is almost completely ready to go. So if we are looking here into our pods, what is happening now? Everything is running. So the next thing we can see is what will happen is that we get Prometheus into the cluster, and we get our policy agent into the cluster. Maybe we can already look if our policy agent has landed. Not yet, but we can basically see what the Flux is doing. So if we go to Flux here, we can see that it's connecting to this Git repo, and it's using these customizations. But with it, we're going to have the chance, and we can see our Lens is doing a nice job, but we have as well the very nice proper Weave GitOps UI. So let's see what is happening. So now everything is running. So we have Prometheus. We have as well, let me check, do we have already our policy agent? We should. Yes. Let me wait. Do we have the policy agent? Not yet. One more second. There should be the next thing which gets into the cluster. Megalix, here it is. And it already sucked in 3 standard policies. So this is part of the Helm chart. This is just to show how much flexibility you have. You can even define directly as part of your Helm chart some policies that directly get reconciled and sucked in. And I didn't check the time, but this is now a fully operating cluster. So the next thing we're gonna do is we're gonna add some additional policies. And what we're gonna do is, let's first check events if everything is good. Let's check all namespaces. Let's see if, yeah, I think all looks good, all looks happy. So yeah, let's continue. So what we're gonna do is, let me go back to my window here, is we're gonna now add some policies. And for this, I need my Visual Studio Code. So what we're gonna do is, if you look, for example, this is an order cluster I have, and these are two policies I have in this order cluster. And let's say I really like this policy, so I want to take them over. So what I'm going to do is a typical flow in GitOps, right? You copy and paste. So what we're going to do is we're going to pull, oh, this was bad. Git pull. And we can see that our liquid 25 cluster appeared, and we go to system, and we're gonna create, first of all, a new branch. Let's call it create our branch add. So this is actually policy as code, right? So this is what we are doing. Add policy to cluster liquid add. Let's call this add new policy, because we already have some policy in place. So now in this branch, we're gonna add our policy folder. And what we're gonna do now is we're gonna commit this, add policy. And we're gonna publish our change. Yeah. I know this. So this is a weird error. Let me. Done. So, and again, right, what we did is operating by pull request. So if I go now to my repo here, this is the repo we're operating against. We can already see that my pull request has landed. So this is now, if we go and check, we're going to create first a pull request. We're going to see the files that have changed. This is the two policies we want to suck in to reconcile. So, and I think we're just going to move forward with this. So we're going to merge this pull request, and we should be good. So, true. So what I need to do quickly is this is a small error. We changed the namespace. So I need quickly to adapt one of the policies, which is container running as root. And I have seen the error. So what I'm going to do is I need to change the namespace. It must be excluded because it's not kube system. It's basically VSCode system. So this should fix our first error event. Which is this warning, which is happening in the namespace VSCode system. And now we're gonna just wait that Flux will basically suck in our new policies, and we should see this land if we go back now to our customization. Let's give it a second so they can reconcile. Known, reconciliation in progress, and everything works. This should go through this time. Let's hope for the best. So this is basically the interval every time Flux is trying to reconcile, and if it succeeds, it will say the state is true. So yeah, we can see everything went through, and this is how we did policy. And to make sure that the policies really landed, we can now, if we go to policy, we can see that these policies we merged in our Git repo appeared here. So this is how you can do policy as code, as a very simple example. So what we did is basically we brought up a cluster. It already had some policies. You're actually free to define whatever policies you want, and you can basically have them in a Git repo and they get automatically reconciled as a platform operator, or you can later on edit and manage your policies through Git. And this is basically it. And now we want to see the last thing, right? Is how does this protect us, right? And for this, we're gonna hit our admission controller. And basically what I'm gonna do is I'm gonna hit, I have here violation.yaml. So if we want to see what we are hitting the cluster, we can, let me find my VSCode. Let me open the file open. This is the wrong one. We want to open violation.yaml. So this is the YAML we're gonna hit basically our cluster with. And I'm not gonna do this in a GitOps fashion because we have limited time. I'm directly gonna hit basically it via kubectl. But you can see we already fixed one error. And if you remember, basically Flux will, in the reconciliation error, it will basically tell you what is going wrong. So if we hit now with this, I already did this before, I'm a bit sorry, but I'm going to change my kubeconfig to cluster 25. Let me do this clear. And now I'm gonna, let me just check that I'm doing everything correct. Sorry, this is live, so everything is not perfect. So, but I'm now hitting my cluster, and you can see I'm hitting basically this violation. So the admission controller prevented this is even happening, right? So it's telling me that the replica count must be greater than 2. Found one. So this is basically how policy is really preventing you that even bad things happen. And if you are wondering how this looks through GitOps, we can as well see if we go to this error is emitted, yes, as well directly through the system, and you can see this is happening. So when the reconciliation, do we have a reconciliation error? Yes, somewhere. Okay, this is basically it. And now I will give over to Mustafa, who will show us commit time prevention.
All right, thanks, David. Let me share my screen quickly. Can you confirm that you guys see my screen?
Yes.
Right, perfect. Right, so before I dive into the demo for the commit time validation, I just wanted to show you the policy libraries that you can get whenever you install GitOps Enterprise. So we have a couple of hundred policies that will cover many security compliance aspects, things that you can use in your organizational standards. And also this policy will cover specific benchmarks, something like PCI, SOC 2, and other benchmarks. So basically, this is what you get. These are all hosted in Git, and as David showed you, it will follow the GitOps workflow. If you drill down in a specific policy, you would find the code for that policy written in Argo here. And we have a couple of metadata with the policy to help whoever working with that policy violation to understand the policy, to see what this category of policies it is, and how to actually remediate this policy. So just wanted to show you that before we dive into the commit time. All right. So, okay, so what David showed us is basically having a guardrail in the runtime, preventing your clusters from getting any violating changes. But from a developer perspective, what they will go through is, right, I have some changes in my code. I commit these changes, push it, wait for the CI pipeline to build it, and have Flux deploying my changes, and then get a violation that I have made something wrong. And for me to fix it, I will go back to my code, fix that, and go through the whole process again to see the violation, if it's fixed or not. And that's basically a waste of time for the developer, time that can be used in innovation and being productive. So what we did here is shift the security far to the left and have that policy checks into the commit time and enable the developers to have early checks and the early feedback and detect the policy violations at commit time. So let me show you how that will work. Okay, so typically I am a developer in my VS Code doing some changes. Let's see, I want to change my replica count instead of 2, increase it to 3. And maybe I do something wrong here, which is I want to allow privilege escalation and set it to true, which is basically a violation to a policy. But maybe I don't know the violation, or I forgot about it, or maybe I'm new here in the team and I don't know about the policy checks that's being set up. So I continue with my workflow as a developer. Let me create a new branch here. This. Right, I have my new branch. Let me commit the code. Okay, let me push it. All right, so let me go back into GitHub here. So we have here our branch. Let's create a pull request for it. Okay, so once I create the pull request, some checks will be run. So what this is a GitHub action that will do the policy checks in GitHub and provide me with an early feedback whether I violated the policy or not, and make me realize what policies this is. So let's wait a couple of seconds for the check to be done. All right, so we have a report for the violations. So we have one scanned entity and 1 violations being caught. If I dive into the details, I have a nice report of which policies did I violate. And right now in my case, I have containers running with privilege escalation, and this falls under the category of both security policies, and it's a high severity policy, so I need to actually fix this. So, all right, this is a step where I should fix it. And that's what we got the developers covered. We built a new feature called auto remediation. What that is it creates a pull request, a new one targeting my branch with the fixes that could be suggested to fix this policy violation. So if you go in here, this is a new pull request. And if we can see what changed, oh, here. So we have a new code saying we need to allow privilege escalation and set this flag to false. If I go and merge that pull request into my branch, we got it merged. We go back to our original pull request here, and you can see the checks are being rerun. We'll wait a couple of seconds. And that's basically it. So without too much effort, I got an early feedback. I got my violations fixed. I got a pull request with an auto remediation steps or code that will fix my violation, and all happening at the commit time without actually having to go back and forth between my code and the deployment time checks. And yeah, that's basically it. So I'm gonna hand it back to David for the other demos. Thank you, guys.
Thanks, Mustafa. This is really helpful, shifting even more left. And now finally, we see what we are really excited about. You have seen how cumbersome somehow the exploration is. It took me quite a while to find the error on the customization. So this is, even if Lens is a really great tool, we are very excited about our GitOps UI. And James is gonna now present you our GitOps UI. James.
Thanks, David. Appreciate it. Yeah, so hi, everyone. My name is James Wilson. I'm going to run through Weave GitOps application observability. So this is a feature set that we're building out right now. We're really excited about it. And ultimately, the aim of this is, right, via GitOps, you have a lot of powerful objects that you're working with within Kubernetes. And we want to make it easier to see what those things are doing and make it easier to manage them, just so you have a lot of confidence in how your system is being operated, especially when you have these reconcilers sitting on your cluster that's doing a lot of work for you. And so we're just going to run through the basic kind of setup that we have here right now. We're planning on adding a lot of great features to this in the future. So what you can see here is we have this application screen, and this is kind of the main view that you would have in terms of how your applications are running. And this is really listing out customizations and Helm releases, which are two objects from Flux. And we're trying to make them first-class citizens here. And so as you add customizations and Helm releases to your configuration repo, and they're pulled into your cluster, you'll see them listed on this page. And you can notice too that you can see the different types on which one you're dealing with, the namespace that they're in, the cluster. As you connect multiple clusters, you can get insights across clusters, not just a single view. You can quickly see which sources they're a part of and can quickly jump into the source for that particular application and get some info about that there. And I can jump back quick, as well as, are they healthy? Are they suspended? Are they unhealthy? Which would ultimately be a red check mark here. And you would see the error message listed out here, and what revision that they're currently on as well. And something we'll be adding for Helm releases is that incremental Helm release revision number that gets applied when using Flux. And we're also working on adding just simple ways to quickly filter things down so you can quickly get to what you need to within this list. So when I go and click and drill into one of these, right, I'm given additional insights. So here I can quickly see that I have, this is the Flux system customization. And this is that main reconciliation loop that is created when you run Flux Bootstrap. And so what you have here is the source, the revision, the cluster, as well as the path to your repo. And interval time, we filed a bug for that nice 600 seconds, which should say 0 seconds. And you can get a good sense of, is everything healthy or not? And then we have an events tab here, which gives you events for this customization in particular. So you can quickly drill down and get a sense of what's happening. And you can see earlier, I was trying to set something up and I have these error messages that were being created by Kubernetes because it was failing to reconcile this particular customization. And then if we jump to the reconciliation graph, you can see here, you can get quick insights into the things that are being created by this particular customization. I can come here and zoom in quick, and you can see here that the Helm release is suspended and that the other 3 are healthy and running. And the Helm release is healthy, it's green, but it's paused, meaning if I push any changes to it, it's not going to apply those changes onto the cluster. Something that we're adding as a quick follow-up is the ability to suspend and resume these objects directly from this UI, as well as reconcile. We understand that is a common action for operators and application developers alike as they're configuring Flux. And so we want to make those tools available within this UI as well. Something else to note here too is I'm going to drill into one of the applications we have here. So this is the pod info application. And it's not showing everything that is applicable to this application. For instance, I'm missing the service for this particular application to be able to go in and actually pull up the page. Now, why is that? Well, again, these views are being leveraged. These views are leveraging RBAC, Kubernetes RBAC system. So we're only showing the user what they have access to. And so currently I'm signed in as a user. I can't view services within any namespace. And this is, the application is adhering to those policies and not allowing me to view those at all. And now another screen that we have here is a sources detail screen. And so here we can list out all of your Git repositories, Helm repositories, buckets, and Helm charts. And so you can see here that I have 3 Git repositories listed out and a Helm chart, which is actually being produced by this www-gitops Git repository. And the nice thing about this too is I could quickly click on a link and be taken to that Git repository, the applicable Git repository that source is a part of. And you can, again, quickly see which branch that these sources are referencing, as well as the interval time. How frequently are these updating? And you can see most of them are set at 1 minute, and the pod info one is set at 30 seconds. And so again, we're trying to give you these quick insights into everything that's happening within your Flux system. And then if I go ahead and drill down into one of these, again, this lists all the automations applicable to that particular source. And so you can imagine that if you had a team which had a single repository and multiple microservices within that repo, and so they have multiple customizations for that particular source, they would all be listed out here. They can quickly come and say, oh, all 5 of my customizations associated with this source are healthy and they are reconciling and doing what they're supposed to be doing. And you can notice here too that we have the events tab as well. And then finally, we have the Flux runtime screen. And so there is a small bug here where it's showing more than it should right now. For instance, the pod info shouldn't be here, but all of these controllers should be here. And what is this doing? Well, this is giving you quick insights into how your runtime, right? These are the workhorses of your GitOps pipeline, where these are working hard to reconcile everything that is flowing into Git or the Helm repositories or buckets, and making sure that they get produced and produced onto this cluster. And so you can come here to one, see that they're healthy, two, see what version that they're all currently running on. And again, if you have multiple clusters connected, or you have multiple controllers installed onto your specific cluster, you would see them all listed out here. And so again, we're adding a lot more features to this. This is just the start of it, and we're really excited. David, back to you.
Thanks, this was good, James. So basically, if what I can do is go one more time before I give back to Steve, showing what you have seen today. So you have seen a whole cluster lifecycle platform operator flow where we create clusters via liquid metal, our special. If we can as well provide clusters on any cluster API provider you have in mind. So this is not a problem, but you have seen today liquid metal. We have seen how platform operators can basically use our technology to make sure that all the clusters get the right set of load out in a declarative way, in a GitOps way. We have seen how we make really the fleet management easy and go towards treating cluster as we should treat them, as cattle. We have seen how basically we get automatically make sure that the policy agent is ending on the cluster and instructed via the right policies. We have added policies via GitOps through our platform repo. We have seen how our admission control works. We have even seen how we can shift further left and already make sure that the right things get committed to the cluster via our commit time validation. And we have seen how platform teams and application teams then can really leverage our UI to be more productive and more effective instead of a non-optimized UI like Lens. So, and I hope this was exciting for you. We are very much excited, especially about the new features to come. And with this, I would give back to Steve. Steve. All right. It's, yeah. So
I'm just having problems finding all the right buttons in all the right order, as you do. There we go. So yeah, thanks guys. Yeah, we've pretty much run out of time. We were hoping to take some questions and answers, but we're pretty much bang on the hour now. So unfortunately not, but before we go, some additional resources for you. If you'd like to know a little bit more about trusted delivery, you want to do a bit of background reading on it, we recently published a white paper. There's the URL. If you want to have a play with GitOps tooling, you can download a free edition at the following URL. If you want to see the whole thing and maybe get into an evaluation of that, please reach out to us and we'd be happy to give you a customized demo for your specific requirements. And if that interests you, then we can go on and look at a proof of concept trial in your own environment. Thank you, everybody, for taking the time to watch our presentation.
Thank you, Steve. Thank you, David. Thank you, Mustafa. And thank you, James. And thank you to everyone who joined. You will be sent the recording and the slides tomorrow as well. Goodbye.
Goodbye, everyone.